Thank you for coming to our Edge in Education Making Sense of Mathematics. I'm using this microphone because we are filming this to put onto our website for other parents that are not here. But Caty has her own built-in one, so she doesn't need to hold any microphone. But we have Caty Romero here joining us. She is currently in Thailand working for a full continuum school there. She's Director of Teaching and Learning. Is that your title? Yes. I know her from way back. We were teachers in Mexico together, and then we lived in Chile together, and she at that time was gifted. Did we call it gifted and talented then? Yeah, names have changed since, but and she did a lot of that work across the elementary school, working with how do we differentiate inside the classroom. And then they went to Shanghai, and she continued to do some of that, and then got into coaching, and then really found this area of mathematics. And while she always had it, it was just she started working a little bit with Irma Anderson and helped write the Arrow standards, which are a version of the Common Core standards from the U.S. that international schools use, and then branched out to now she's Director of Learning and does some consulting worldwide. She was here last year, and so she helped work with us in a similar way in terms of how do we understand the conceptual side of mathematics and what are the ways in which our students are engaging in an inquiry-based mathematics program, which ISP has been on a journey. And talking with James, we've had different iterations of this here at ISP, and Nancy as well can speak to this of, when we open up our shelves, we have lots of resources. So it's just a matter of how do we continue to understand this better so we can really help students unpack mathematics and know it really well. So today, Caty's going to help lead us through what does kind of early childhood all the way through up to middle school, what does math kind of look like now in terms of how we help students unpack it in concrete ways. You see a lot of materials there on the table. But Caty's been working this week with our teachers around assessment, understanding our learning targets a little bit better. And so the teachers have had lots of opportunity to be able to be working on their units. And in fact, the units that we're in right now, some of the assessments and things have really been impacted because of that work. So anyway, I'll turn it over to Caty. Thanks for coming.
Thank you. Good morning. That was a great intro. Saved a lot of time so we can start playing. But I always like to start my sessions with parents, just trying to explain why I'm here. I'm just here to share some of the things I've discovered in my journey as a math educator, right? And the only reason why I've had all those jobs that Matt mentioned is because I'm so old. And so I've had the chance to be a homeroom teacher all the way to high school, from kindergarten to high school, and then we moved. My husband and I and Matt and his wife, we worked together in Mexico, my hometown, and Matt's, Mariana's hometown as well. And then we moved to Chile and we worked there, and I had a different job, and I was really diving deep into mathematics with the lens of students that needed more. So I learned a lot about how to differentiate for those students without necessarily giving them the content for the next grade level, but really just making sure that they were challenged to the best of their potential with the content of that grade. And then, like Matt mentioned, we moved to Shanghai, and in Shanghai I was working again with differentiation, but for students that were struggling. And the strategies and the practices were the same. It was really diving deep, having students connect and make sense and extend and visualize and talk to each other. So that's how my passion for working with teachers, working with educators started. Because I realized that a lot of people are very scared of math, right? They love reading and writing, they love science, but they're very nervous with math. And so I started sharing all of the different approaches, right? Practices that we could use to make sure that kids are not nervous. We were nervous, but we're not gonna tell our kids, right? So my first advice of the morning is, don't tell your kids that you were bad at math, and they probably will be bad at math, because then they will be bad at math, right? And so we need to understand that when we learn, when most of us learn, It was all about memorizing. And so that made us very nervous, because maybe you remember, maybe you didn't, right? Today is different. Today's students should be able to use a variety of strategies that will help them get that concept, right? It's gonna work the same, but instead of memorizing 4 times 8, 32, right? Very fast, right? Or 4 times 8, they have to do 4 times 1, 4 times 2, 4 times 3, right? There's different strategies that today will help them know, right? And so that's basically the goal for today. The goal for today is to help us parents. I'm a parent as well. I have 2 kids. They're now in grade 11. They think they know everything, right? And I know as a parent the importance of being able to help at home, right? Or at least when they show you something and you want to yell, that is wrong, right? Like, what are some of the things that we could do to really empower them and make sure that they are the ones doing the learning, right? So if you're at home and you're helping with homework and you're talking, and he's like this or she's like this, there is no learning happening for your child. It's you, right? The person doing the learning is the person doing the talking. So if you're talking, you're telling your kid how to do the algorithm, chances are that they're not understanding. If you want to help your kid, you have to say, talk me through it. Tell me how you do it. And then when they're talking and they're telling you, they will catch themselves with that little misconception, and then that's when you could be like, oh, I wonder if you forgot this place value, or you forgot this or that, right? So that will be the number one thing. For us to remember that math is fun, right? And all of these things that we enjoy and that our kids enjoy, this is math. Puzzles and games, and look at that one in the left, right? That's algebra, right? But instead of letters, we have little happy faces that make it easier for the kids. They love to work on these things, right? Open-ended problems, right? Like ways to combine numbers. That doesn't make kids nervous because it's so open-ended, they can do something very simple and it's still okay. And then little by little, they can feel, okay, I can do this. Maybe it takes me a little bit longer. Maybe I need a little bit of a piece of paper for now. But in the end, it will bring them to be fluent, right? Which is what we want. We want students to be fluent. We want students to be accurate, right? When we talk about mistakes in mathematics, we're not talking about numerical mistakes, right? Math has to be very accurate. Like if they say 4 times 7, 29, we don't celebrate that mistake, right? The mistakes we celebrate is when they realize, oh, I was using the wrong strategy. Oh, I forgot that. Those are the mistakes that were great. Now you know you don't do that one, right? So these all will help us with that myth that some people are good at math and some people are not good at math, right? Especially in elementary, we need to understand that, okay, here comes the secret, but all of the math in elementary can be memorized. Right? You can just memorize it. You memorize the algorithm, you memorize fractions, you memorize the steps. You don't need to know anything. You don't need to understand what are decimals. You just do the algorithm step by step and then move the decimal point to whatever you remember. And so what happens is when they go to middle school and high school, they get nervous because now memory is not enough. Right? So what we want to do is in elementary, in primary years, we want to give them the opportunities to know why something works. Why does the algorithm work? Why, when we are doing fractions, why do we multiply the numerator by the numerator, the denominator by the denominator, but it's different in division? So when kids understand that, we're helping them not just for that grade 4 or grade 5, we're helping them to be mathematicians. We're helping them to be problem solvers, to be like, I don't know that, but wait a second, let me see if I figure out. That's what we want. Yeah, as educators, when we go visit classrooms, as administrators, when we go visit classrooms, and we ask a student, what are you working on? What we want to hear is a student say, I'm trying to figure out how many pens can fit on this box. Or I am trying to figure out how long can this thing be. We don't want students to say, I'm practicing my multiplication. How boring, right? We want them to be able to be solving something that means something, right? Dr. Jo Boller, she has dedicated her whole life to do research on mathematics. Unfortunately, all of her research is in the United States, not so much for us in international schools. But the message for her is just this, is give students opportunity to understand what math is, to play with it, to make sense of it, so they don't rely on memorization. Because all of the research says that students that memorize, those are the ones that don't do well on tests, because they're so nervous thinking about what they have to memorize that they're not thinking, right? There's an example of a test that she writes in her book where students on the SAT, there was a question that was something like, estimate the answer of 11/12 plus 15/16, or something like that, like big numbers, 11/12 and 15/16. And there were 4 answers there. 85% of the students got it wrong because they were doing calculations. So imagine multiplying 15s and 16s and 11s and 12s. There's a lot of room for error. What was expected of them was to understand that 11/12 is almost 1, right? And 15/16, it's almost 1. And one of the answers was 2. It's in the book. The book is called What's Math Got to Do With It? And she put a picture of that. And one of the options was 2. 85% of the students didn't get it. So what does that tell you? That students are used to, oh, I better do this calculation, right? And so what we want is opposite of that. We want to make sure that students are getting ready to be mathematicians of the world, not just to pass this test in 2nd grade or pass this test in 3rd grade. We want to make sure that they choose careers with mathematics. There's a lot of students that choose a career because it has no math, right? And we lose a lot of kids that could go in those professions and really make a change because they don't feel secure in their math. So it is our job in primary years to start that and to make sure that they all feel that they can do it, right? So all of this week, like Matt was saying, in a partnership with Miss Nancy, who is the math leader in the elementary, and James, who is the coach, the instructional coach I'm sorry, I keep saying elementary, in the primary, yes? So the 3 of us were together, and Matt were together with all of the teams, from the younger kids all the way to grade 5. Just talking about this. What are we gonna do? How are we gonna make sure that we are preparing our students here at ISP for after high school, not just for this little unit, right? So what do we know? We know that students learn best when they visualize, when they explain, when they connect, and then when they make sense of math, right? So today, as you can see, we have lots of toys on the table. So this is what we're gonna be doing. We're gonna visualize what that looks like. We're gonna try and explain it to each other. We're gonna make connections between addition and subtraction, multiplication and division, right? And we're gonna make sense of it. Is it something that we could do through an algorithm? Yes. Yes. But why do we need to do it in a different way? To build those experiences that kids can reach out to when they don't know what to do.
Can you what do you mean by algorithm maybe?
That
might not be a term
that we use here. Oh, that's great. That's very good. So an algorithm is, for example, when we are multiplying, right? And just the one that just follows the steps, right? This by this, we put it here, and then we carry, right? Which is not a mathematical term, and you add. We'll do some of that in a moment. And what we're gonna do is we're gonna take some steps back to see all of the different strategies that we could use before we get to an algorithm where we're just following steps, yeah? I'm not saying that the algorithm is bad at all. I'm just saying that having students understand that there's different ways gives them a little bit more power to be like, oh, this is how I solve it. And some students will eventually get there, yeah? So right now, we're basically gonna work on two things. We're gonna be modeling, we're gonna be using the manipulatives, and we're going to move from a concrete strategy to a pictorial strategy to then a more abstract strategy. Yeah, that's what we're gonna be doing. And then we're gonna be explaining our thinking, communicating with our partners. Also, I don't know about you, but in the past when I grew up, I always did math on my own. At my desk, on my notebook, quiet, right? Fast, ideally fast, right? And today we know that we want to work with others, right? We want to be able to be listening to how others are thinking about it, and that's also how we learn. So basically, in the past, it used to be just the content. And the content has not changed. The content is the same. The standards that we are using here at ISP are the same. The only thing that is changing is the approach, in the sense that we also want students to problem solve, to communicate and reason, and also to model, right? But the standards are the same, the fluency is the same, they're going to be as prepared, but better prepared because they'll have more strategies, yeah? So we're gonna start with a fun number talk. Yes, a number talk is like a little warm-up. It's a warm-up like when you play a sport and you do your warm-up before you go play the game. So in this warm-up, we are not going to use paper and pencil. We're just gonna try and solve it in our head, yeah? And I'm not gonna ask anybody, don't worry. You'll get the chance to talk to your friend, talk to your partner, tell them how you solve it. This will give you the chance to explain, and if you don't know how to do it, then your partner will know. So we're all safe. Sound good? So, yes. Yes, yes. Move now if you need to. Nobody wants to be the principal, right? All right, excellent. So we're gonna do a little thinking, all right, friends? When I put the problem in there, we're not gonna immediately say the answer, right? We think. I'm gonna give you 30 seconds, more or less, 35, and then you talk to your partner. Sound good? Let's get ready. No paper, no pencil. So now, after you had the chance to practice with your partner, who would like to share how you or your partner solved? So she thought about traditional algorithms, so like this?
Yep.
Yeah, that's the one.
And then?
She took one from the 9 and put it to the 7.
Why would you take one from the 9?
Because 7 minus 8 is minus 1.
Good. So 7 minus 8 is minus 1, right? So you need a 1 over here. And then?
Make it 8.
Okay. And what do I do with a 1?
Put it next to 7.
Okay. So I know this is obvious, but in this practice, we are helping students use place value vocabulary to explain their strategy, right? And so if this was my classroom, I would be paraphrasing and say, okay, so this, you took a 10 from the 9, right? You took because it's a 90, so of course you have. So now it's an 80, and this 10, we put it here, so now it's 17. Yeah? And then?
17 minus 8, you have 9.
Okay.
And then you do 8 minus 3, which is 5.
Good. So I would say, so 80 minus 30, or 8 tens minus 3 tens. Which one do you like?
80 minus 30.
Okay, 80 minus 30 is 50, and the 5 is here because look, I'm in the tens columns, right? So calling their numbers with their value, they're correct. And if I was the teacher, I would say with their last name, right? Like they are tens, or they're ones, or they're hundreds. Yeah? All right. Did anybody do something similar? This is the algorithm when I was talking about it, right? This is an algorithm. It's a set of steps that help us very quickly, right? Some people say I borrow from the neighbor, but that's not true. The truth is that you have 7 minus 8, well, you need 10, right? But you do have Like if you go to the store and you have 97, you have 90 and 7, and you're going to buy something for 38, you're not going to be like, oh, I don't have no money, I better leave. No, you pay with your 90, right? You don't have the eight ones, but you have more, right? Great. Another strategy. Thank you for sharing. Who did it differently? Yeah. Yes.
Yeah.
Yes.
I usually look where, let's say, where the nearest decimal is, or the most useful decimal.
Okay.
In this way, it could have, in this equation, it could have gone either way, but I did like 97 minus 40, and then the additional 2 as well.
So you changed these 2 plus 2 to make it an easy one, right? A friendly 10, we call it a friendly 10. So 97 minus 40 is?
75. Sorry, 57, sorry, that's my home.
57, and then?
And then plus 2 is 59.
And then you have to return those 2 that you borrowed, right? Very good. Excellent. And what's your name?
Dina.
Oh, that will be very difficult, Dina. Okay. So this is Dina's strategy. And this was Ella, E-L-L-L? L-L-A. And this is Ella's strategy. Excellent. Did anybody do it similar to Dina? Okay, so Dina used a combination. I wouldn't say this to my kids, but this is a combination of 2 strategies, right? Like you're compensating in a way, but then you're subtracting by parts, right? Thank you, Dina. Who wants to share another way to solve this?
Actually,
Yes.
at a glance, so then we could guess it could be something a little more than 50. So this is really obvious. Then I have, no, actually, so no calculation still, but when I see it, then, it should be like 50 or a little above. So then 38 plus 50 makes 88. So then the difference is 9. So then 9 plus, then plus 9, then 59.
Okay, wait a second. Let's do it again. So I got to the 50, so 38 plus 50.
No, actually, no, because this is a guess base.
Yes, a guess and check, yes.
So then the answer should be something a little more than 50.
A little, you're estimating.
Yes.
Yeah.
Yes.
And then?
So then this is a proof.
Yes.
38 plus 50
Yes.
makes 88.
Yes.
So the difference between 97 and 88. So then 97 minus 88. So this is 9.
Yes.
So then finally 50 plus 9. Yeah.
Very good. Thank you. And what's your name?
Ayako.
A-Y.
A-K-O.
Like this? Ayako strategy, right? So kids would be like, woo, right? But if I teach the strategy, the kids will be like, oh my goodness, this woman is crazy, right? But if a student shares a strategy, they'll be like, oh, I wonder if I could try the strategy with another number, right? Which of these strategies is the most efficient? Gina's? For Ayako, for her is that one, right? It's the one that works for that student. If it's fast and accurate, that's the most efficient strategy, right? The algorithm in this case got you to the correct answer. But if it was a problem where it's hard to picture it in the air and the answer is wrong, then that's not the best strategy. If a student tries to do tally marks, that's not the most efficient strategy. It was in first grade, but not for this problem, right? Okay, let's just do one last one. One other strategy that we have. Yes, over there?
Just make it very easy for me.
Yes.
So take the big numbers. 90 minus 30 is like 60. And then it's like 67 minus 8. It's easy already.
90 minus 30 is 60.
So then I do like 67 minus 8. And that's the easy thing.
Oh, 67. And 67 minus 8. Right? So you kind of decompose the 38 into 30 and 8.
Yeah, I use this like, I
Yeah.
like to count in tens and
Yes.
because it's easy. So
Yes.
I just use this easy way. And then just like finish the...
See how many times she said easy? Is this easy? Is this the most efficient strategy for her? Yes. Is it based on place value? Yes. Right? There's no tricks in the hands or in the knuckles, right? It's you decompose the 30 and the 8. In this one here, first, and in Dina's, she made it a 40. In the purple one, I don't want to say your name incorrect, Ayoko. In that one, she used the guess and check, right? Whatever strategy that works for you is the best, yeah? Another strategy that we could use that I would like to teach my students in second grade, it's a problem for second grade, would be a strategy of like a balance, right? Making a balance, which whatever you do to one side, you do to the other side. So it's a little similar to Dina's because I'm gonna make a friendly 10, right? So I could even make the 38 a 40, or I can make the 97 a 100. It doesn't matter. Both work. So let's say I wanna make this 100, then I add 3 here, and I add 3 here. So 100 minus 41. 100 minus 40 is 60, minus 159. Boom. Yeah. Yes?
You go 97 minus 30, and then just minus 8.
Yep, that's what happened here.
Yeah.
That was the strategy. So, somebody already shared that.
You could also just make it 37. 97 takes
Yeah.
37. Or 91.
Yeah. But we're not looking for one, right, strategy. The goal for this is to understand that there are many ways to do this. When we were studying, we always needed to find the one strategy that the teacher taught, and that's the one we had to use. And then we had to do 20 of them on a piece of paper alone quiet, right? Today is different. It's a process that helps students understand what is it that we can do to solve. Not what do you need to do. We saw it yesterday, you should know it, right? So this one, the compensating strategy, right, in this case, helps, for example, if we do 40, right, if we make, instead of the friendly number 100, the friendly number the 40, it also works, right, 99 minus 40. So this strategy only works with this, with subtraction. If it's addition, it's a little bit different. But the goal, and I wanted to show you this, right, this would not be good. People think about it in many different ways, right? Sometimes they decompose both. Sometimes they decompose one. What matters is that the more opportunities we give our kids in the primary to see that there's many ways to do it, the more relaxed they can be. Somebody could use a number line. Can you picture a number line? Like from 97, maybe somebody wants to jump back. Or maybe somebody is in 38 and then they want to jump up. So you can solve this problem by addition or subtraction, right? Some students don't want to make mistakes and they go by tens, right? 48, 58, 68, 98. Ooh, one less. So we are going to get to play with the manipulatives because one important thing, friends, is that parents is this. To get to these, kids need to play, right? If you just give them this, they'll be like, what? I need a piece of paper, right? But if we give them opportunities to play, which we're going to do right now, then they're going to be able to be like, yeah, I can do this, I can do this, I can break it apart. Of course, if I have 97, I can take a 10, right? They will know all of these strategies, right? So just like I said, it's not just about the test, it's about understanding, modeling, being confident to say, this is the strategy that works for me, this is what I did first, right? I agree with so-and-so, right? And knowing that problem solving is so much more than just a little word problem. Problem solving is when they have to think about what are some of the different ways, right, that I can make 24 cookies. It's so much more than just the factors of 24, right? If somebody said, well, I want to make, you can do 6 rows of 4 or 8 rows of 3, or maybe somebody said I can do one row of 24. Really? Do we have cookie trays that long? So in this problem, 1 and 24 is not the best one. But if we ask factors, there's no thinking, right? So modeling is what we are going to do right now, which is going from a concrete, manipulative, moving into a pictorial strategy, to then move into abstract strategies, all right? I had a parent one day at a coffee talk like this, a morning talk, that said, well, do you expect my kid to go to university with this manipulative? No, I hope not. I hope they make it to university without it. But it is our job to give them plenty of opportunities for them to build all the different pathways so they can be fluent and they can use any strategy that is abstract. Yes? So we're going to try and trust the model, all right? So these are some of the things that we're going to be working on. We're going to try and build an area model. We're going to decompose numbers. We're going to build bar models, which is so important to be ready for algebra. And then at the end, we are going to finish with a problem for grade 10. Oh, we're going to multiply binomials, and you're going to do it like this. You're going to be able to do it, build it, draw it, and solve it, all right, in just this little bit of time. Sound good? We feel confident? All right, excellent. So at your table, we're going to start with let me put my camera on. All right, we'll start with the double-sided coins that you have at your table. And you have whiteboard, marker, and double-sided coins. All right. So our first problem, this is called a 10 frame, right? Students start with a 5 frame in pre-K4, and then they move to a 10 frame, right? And this is very important for students to start subitizing, right? Like really understanding this is 5 and this is 3. This manipulative was created to replace the hands, right? Like when kids say, how old are you? They say, right? They don't say, right? Or, right? Students say, how old are you? Right? And so that's the 5 is the one that they don't need to say, I am 1, 2, 3, 4, 5, 6. They know this is 5, and then they just say, I'm 6, or I'm 7 and 8. You know how old are you? 10 and 2, right? Nobody was 6 and 6 more, right? And so this manipulative has the exact same purpose. It's for students to know this is 5, and then this is 5. So if one is missing, that's a 9, right? If you're missing 4, that's a 6, right? So this is so easy for kids. They immediately make that connection. So having said that, our first problem is going to be, without using pencils, please, let's do 9 plus 3. What do you think kids would do using the 10 frames and the double-sided coins for this problem? Can you do it? 9 plus 3. Can we use your example? All right. So what did you do here? You had 9. Who did this one?
Oh,
yeah, tell me what you did. Move your blue where it was. There you go. So you did 9 in 1 and 3 in 1. Who else did that? Everybody? Yeah? Okay. I didn't say anything. I didn't say you had to use 2 colors. Right? So this is what naturally happens. Students are understanding 1 and 1. And then? And then you moved it?
And then we moved it because, as you said, the idea was this was the 10.
Yeah.
So then it just means that you just have to add the 2, which would be 12.
Yeah. You made a 10, right?
Yeah.
Now you wanted to be a little creative?
Not really.
Yeah? Okay.
Just easy for me like this.
Okay, like this. And then how would you show us the answer?
9 blue, 3 red.
Okay. So you want to do it here?
Kinda.
Yeah. Kind of, yeah.
Or actually, I mean, then
Yes.
we did move one coin
Yeah?
here.
Okay.
But because the question was more like, how would a child? So
Yes.
we kind of stopped there where they would.
Yes.
say, yeah,
Yes.
be in the equation.
And if he is, this is my kid, right, in grade 1, and if he refuses, I don't want to put it there. She did that. I'm different. But if he says, but I know it's 12, because 9, 10, 11, 12, great. Right? Because he used his, if he just says, I just know it, then I would push. I just know it. magically came to my head, right? Like you did something.
Yeah.
In your head, you either like made a 10 in your head, right?
Yeah.
Did anybody do, you guys did the same? Anybody do something different? Okay. Some students might do this, right? So we have this, right? Some students will be funny and then they will make another 5 here. Well, that's okay, right? It still is 5, 5, and 2. But usually they go to the 10. They make a 10, right? So this will be the strategy for that. This will be the strategy for concrete, right? If we go to a little more pictorial, what we would like for students to do would be to decompose this, and then, oops, sorry, the other way. Decompose this, and they make a 10. See how it's a little picture, right? Why do we want this? Because we want them, when they get 9 plus 3, we want them to think 12, as opposed to 10, 11, 12, right? If we have, for example, 16 plus 5, right? Students will do 16, 17, 18, 19, 20, 20. Yes, you could do that. Or you could think 16, 4, 21. And that is fluency. Fluency will be when students have the ability to make a 10, to make it easier, and then got it, right? So let's move to subtraction, all right? I'm gonna give you 15, take away 8. Can we do that? Let's do 15, take away 8 in your base 10, in your 10 frames. Where did they go? They're gone? And that's the key, right? Take away means that they're gone. They're gone. It is take away, right? Some students, you guys have the 2 colors to represent the ones that are gone, and that's good. That's okay. Eventually, we want them to take them away, right? So they're not confused. What did you remove first when it was minus what? I forgot. Minus 8.
Minus 8. So we put the 15, and
Yeah.
then I was taking the 8.
How did you take the 8? First, your 5? You took your 5 first and the 3, or did you do the 3 and then the 5?
I think I just took the 8.
We don't remember. Okay, all
I
right.
was taking by ones. By ones.
You were taking 1 by 1, all right. And that's okay, right? It's a small number. Ideally, they will take 5 and 3, or 3 and 8, right? That decomposing of that number is so important. And that is fluency in kindergarten. The fluency to 10. In first grade is fluency to 20, right? For students to be manipulated. Now we're gonna go to like January grade 1. We're graduating, okay? And now we are going to use the base 10 blocks, yeah? So you can put your 10 frames away and bring your base 10 blocks. All right. Using your base 10 blocks, can you please solve 48 plus 23? Using your base 10 blocks, 48 plus 23. All right, we got it. Let's go to a table that I haven't shown this, yeah? Should we use yours? All right, oh, look at that, you're super achiever. All right, friends. Can you show me from the get-go? Yeah. Can we look on the screen? All right, so we have 40 and 8 and 20 and 3. What will be step 1?
So do you want to show them what you did first?
Yeah, what do you do first? Okay,
2 over to make 50.
okay,
Then we slid over 20.
Good.
And then we have that 1.
right? Who moved the 10s first? Right? Usually students will move the 10s first and then the 1s, right? That will be more, a little bit more common. But if this is what happens, now what do we do with the 10 1s? We exchange them. Can we exchange them? Exchange them for a 10. There you go. 41. Right? We exchange them. And so this is very important in our place value system that we teach students, right? 10 ones make a 10, just like 10 cents, right, etc. And then this is foundation for subtraction, for them to understand if I don't have enough, I exchange. So I wouldn't wait for subtraction to teach the neighbor, go to the neighbor because you don't have. Exchange happens in addition. So when it comes to subtraction, easily. Look at over here, right? It's a representation of what happened. They took the 2, they put it in there, and then they had the 21, right? And we made a 10, okay? So what are some other strategies that could happen after this? I'm sorry, it's so blurry. Stopping now. Some people complain when I do that. All right, so we did this. We did the 40, right, and the 8, and then we exchange. In the end, we have, what's our answer? 2, 4, 6, 7, correct? Is this correct? All right, so one strategy after this would be decomposing, which is similar to what they did in that team over there. Right? So students usually do the 10s first, and then the 1s. And then this is a 10 right there, right? So 71. This is called decomposing, is the most popular strategy in grade 2, right, Miss Nancy? They love it. It gets to be a little bit messy when the numbers are bigger, right? And so we want to show students how there's another way to do it, which very similar to this, just a little bit more organized. Yeah, look at this. Better? It's the same thing, right? And then usually they do 40 and 20. They do this first, and then they do this. Right? Easily. Another strategy after that is still one less than the algorithm. Right? Let's see if I have enough space here. I'm going to put it here. So it's a little bit similar in the sense that it aligns like this, but it allows students to do the 10s first. 40 plus 20, 60, 8 plus 3, 11. Right? After that, then students, and they all know this one, right? So we barely need to do any teaching. But 8 plus 3 is 11. So, of course, is this 11, is this 11, is this 11. So 1, 1, and 1, 10. So it doesn't fly to the neighbor. There's no neighbors. And 11 is a 10 and a 1. So the 10s go here. 1 10 and 4 10s and 2 10s, 7 10s. You see? So there's a whole range of fun things that someone did to get to the algorithm. And why are we going to just not let the kids explore all that fun and just memorize that, right? Oops, I didn't even show you the whole thing, I'm sorry. All right? This strategy is called partial sums. You can Google it. And there is partial sums, partial differences, partial products, and partial quotients. And it's the strategy before the algorithm. Yeah, that would be ideal. If kids get all of those, then eventually they move to the algorithm. Yeah? Let's do a subtraction. All right? Delete your boards. Let's do one subtraction. Let's move to 3rd grade, I guess, right? Okay, you passed, you skipped. No, we did first, we did second, let's do 3rd. Okay. Yeah, let's do something simple. 126, take away 48. Let's do this. Yeah? You have 100 in there. Okay, let's do it. Did somebody build the 48 with the base 10s? one very important thing for subtraction, you don't build the 48 because you don't have it, right? So kids would just build this, not the 48, right? That will be this is how they really understand subtraction. Instead of giving them a problem and they're like, do I add? Do I subtract? Do I divide? Kind of like a guessing game. If you remove, if you drank it, if you ate it, if you spent it, if you shared it, it's gone. That's when you subtract. So we have 126 minus 40. Yes?
To just show how flexible we want to be.
Yes.
I could start with 40, and
Yes.
then I add on to that and build up.
Yes? Yes? Yes, that is correct. Did anybody thought about that? Yeah, you could do that. If you wanted to do a number line, absolutely.
It's not efficient.
And you jump. But it depends on your jumps, you know, but if you jump a lot, if you do like a 40 jump and then another 40 jump, it's not that bad. Yeah? Now using the base 10 blocks, when you had to do this, were you all nervous because you don't have 40? Were you nervous? No, right? Because you have. So when we teach the algorithm and kids look, oh, the number on the bottom is bigger. Oh, you know that it is true. You have to go back, and then this is a 0. And then if you have a 0, then it has to be a 9, right? And then it's a 9, but then it's an 8. Like, kids get very nervous when they have to do subtraction with regrouping. But when you do base 10 blocks, no one's nervous because they know that they have 6, 8, 10. Can you see it? So this is the same number. Now I'm just going to take my 40. 40. Goodbye. And then I take the 8. Are we nervous about the 8? No, right? We just take this 6. And we know we need to take another 2 from here. So I bring 8. Correct? Did I count correctly? Yeah, I think so. Is this the right answer? Yeah? So how does this look like with a subtraction? Right? How will this look like over here? Well, let's think about what we did. We really decomposed all our number, right? We decomposed it so we could have enough. So what can we do over here? What can we do so we have enough? Okay, so this is a 40, and this is an 8. I could decompose this into 126. That's what I did first. I had my hundreds. I took the 40 from my 100, didn't I? So 100 minus 40 is 60, and 26 minus 8 is 16? 18. Not 16, 18.
Just checking you.
Yes. I was checking to see if James was paying attention. Right? So messy. Is this so messy? Yes, right? It's very messy. Let's see if we could do another strategy, okay? We could do 126 minus 48. What if we do the strategy that we know? 128 minus 50. Does that work? So maybe for this problem, I don't need an algorithm, right? It's friendly enough because the 48 is so close. But if we needed an algorithm, that's okay, as long as students are using place value. All right? So 6, I'll show you the partial differences first. 6 minus 8 is I need 2, right? 20 minus 40 is I need 20, correct? And 100 minus nothing is 100. So you just go backwards, 100 minus 20, and then minus 2. Wow. Right? And it's not negative numbers. It's like, yeah, 6 minus 8, well, I need 2. 20 minus 40, I need 20. And then 100 minus 0 is 100. So 100 minus 20 is 80 minus 2, 78. Right? But if your kids are dying for an algorithm, no problem. Okay? No problem. It just has to be 8 minus 16. Well, I'm going to take a 10 from here and put it here. 16 minus 8 is 8. Now again, 1 10 minus 4 10s. No, this is where it gets tricky, right? So then here what? How can I take it from here? This is the part that confuses kids. I don't even know what to say. You disappear it, and then what? Right, so in this case, the algorithm seems to be the least friendly, right? Yeah? Okay, we have to graduate 9:38. We have to do a grade 4 problem, and then we jump straight to grade 10. Yes? Straight to grade 10. All right. Very quickly. Yes. All right. Very quickly, with your base 10 blocks, we're going to do grade 4. 13 times 12 with your base 10s. What should we do? 13 times 10 times 12. Come on, friends. So in 3rd grade, students learn a lot about arrays and columns. Who's here has kids in grade 3? Yeah, so a lot of arrays and columns for 5 times 7, for 8 times 7, right? Instead of memorizing, lots of rows. So a student could do a group of 12 and then do it 13 times. They could do that, right? Or we could do an area model. An area model is always a rectangle or a square, right? Just like getting area of your swimming pool or area of your garden. So we could use the base 10 to show the problem. So look in here. This is just the outline of the problem. We're not solving it. This is 10 and 2, and this is 10 and 3. I haven't done any math, right? 10 times 10 is 100, correct? 10 times 2, right? 10 times 2, 20. And 10 times 3, 10 times 3 is 30. And the last one will be what? 2 times 3, 6. Yes? So let's see if this is the answer. 100, 20 and 30, 50 and 6. 156. Is that correct? Yes. Right? This is a very efficient strategy when we're multiplying 2 digits by 2 digits. It can also work with 3 digits by 3 digits. Just gets a little bit bigger. It's a beautiful strategy for multiplying decimals, for students to understand what is it to multiply by 0.5. Well, that's a half. If we multiply something by 5, it's a half of that, right? So it really helps students understand. This is called area model, concrete, because it's with concrete manipulatives. Students could do area model pictorial, where they label the 10 and the 3, or the 2, just to make it the same. And then the 10 and the 3. 10 times 10 is 100. 10 times 3 is 30. And 2 times 3 is 6. Then they can add here, right? And 156. So some students, and parents say, but why do we have to do the area model? Why can't they just do, 13 times 12? I'm going to show you why. When students go to grade 9 and 10, and they multiply binomials, they're multiplying binomials, and they use this manipulative, which is called algebra tiles, right? It has the red because you can do positives and negatives. The algebra tiles are the exact same thing as the base 10 blocks. They're just a little bit smaller, right? You could do it with this, right? You could do it with this, but at ISP we have all the algebra tiles for middle school. This is for middle school. So this square is the x squared. This is an x, and this is a 1. All right? So let's try and solve. Using this, you can use the same thing. we try and solve x plus 3 times x plus 2. Right? X plus 3 times x plus 2. How would you do that? We're using the algebra tiles just to outline the problem, yeah? X plus 2, and then x plus 3. Yeah? One thing that is very important when students are in algebra, right? I don't know about you, but I had a hard time understanding the difference between x plus x and x times x. I never understood when was x squared and when it was 2x. It wasn't that clear to me because it was just so abstract, right? In here, when you have x times x, you think about your swimming pool. If your swimming pool is x times x, well, of course it's x squared. So x times x can never be 2x because it's x times x. So that is something that our students will not struggle with, right? So x times x. Now x times 2, well, that's 2x, right? X times 2 is x and another x. So it's not this concept that is over there. It's like you grab it. X plus x, well, you have them in your hand. It's like being in kindergarten again, right? 2x. And then x times 3 will be, tell me, 3x. 3x. And 2 times 3 is 6. So who can tell me the answer to this algebra equation? What's the answer? Anybody give it a go? I'm missing one. What's the answer? It's right there. Just don't look at the problem. This is the problem. This doesn't count as answer. The answer is inside. What is this? 1, 2, 3, 4, 5. Do you guys agree? Right? And it could be opposite. You know how sometimes the teachers give, do you guys remember when you were in high school that the teacher give you this and then they ask you to simplify it so you could give the two simple equations, right? You could, if they get this, the kids build this and they know what are the factors on the outside, right? When I learned, I used that strategy, was called FOIL. Do you guys remember? F-O-I-L, right? And then you just follow the steps of this and this and this and this and this and this. Yes. Yes, distributive property and making sure you didn't forget it, and then hopefully you remember the x times x is different than x plus x, yeah? So in grade 4, when students say, why do I have to do an area model? This is why. Because you are learning a model. You're not learning 13 times 12. If you want to know 13 times 12, you can use your calculator. What you're learning is a model. When we're using a number line, we're learning a model. When they're using a tape diagram, they're learning a model, right? So Matt wanted us to do, who's grade 5 in here? So let's do just a quick one, right? So you have, in grade 5, we don't use the algebra tiles yet. We continue with this. But this has many values, right? Up to, in grade 5, they use this as 100. Remember how we used it as 100? So when we start decimals, guess what? Now this is 1. Put it in your head. This is 1. Yeah? So if this is 1, what is this? 1/10, right? How do we write that down? How do we write 1/10? We can write it like this, yeah? Or we can write it like this. Correct? We agree? All right, so if that is 1, what is this? .01? And what is it called? 100th, because there's 100 of these inside, right? So this is 0.01, and it's 100th. 100th, right? So that's a huge thing for the kids to understand. When they're just playing with the zeros, they don't understand. That is a huge difference between this and this, right? Like if this is 1 million euros, this is nothing like that. That's a tenth of that. If this is 1 million euros, oh my goodness, that is way less, right? So understanding is not about the zero, it's about the proportion of it, right? Now, when we add decimals, that's kind of easy, right? Like you can add, I don't know, for example, 2/10 plus 8. Okay, so that's easy for the kids, right? They do 2 and they do the 8s, right? But let's do a multiplication. Yeah, let's do a multiplication. Multiplication is groups of, right? For example, 3 times 4 is 3 groups of 4. Yes? So let's do 3/10 times 4/10. What is this? Can you make sense of it? Look at that. How can we represent 3/10 and 4/10? All right? So 3/10 will be 3 yellows, right? So that is what we have. We have 3/10. And what we want is 4/10 of that, right? So the real name for multiplication you want to teach your kids is of, right? 3 groups of 4. This is 3/10 of 4/10. So if this is all I have, I just want 4/10. I only want 4/10 of that. I want 1, 2, 3, 4. This is all I want. How many are those? How many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 what? 12 hundredths. Right? Let's say that instead of 3/10, we had 1 and 3/10. Let's say that we had 1 and 3/10. Now what? Can you see the board? Let's say you had 1 and 3/10, and you want 4/10 of that. So now you want 4/10 of all of that. Now what do I have? What is this? 10, 20, 30, 40 plus the 12. How much is that? 52. 52 what? 52 hundredths, right? So in this case, there's no such thing as moving the decimals to the left and to the right and these little dents. It's just what do you have? What do you have, right? Can we do an area model with this? Let's see. 1.3 times 4. 4 times 1 is 4. One group of 4/10 is 4/10. And 4/10 of these would be 12. This is not forever, okay? In the future, we're going to use a calculator. The kids do not need to be experts in multiplying decimals. They need to be experts in understanding more or less how much is that. Like if something is 2.50 and it is half price, they should know that it's less than the original price, right? That's what they need to know. If something is 7.30 plus taxes, they should know that it's more than that, more or less. Like if the taxes are 0.2, 0.3, they should know it's a little bit, right? Sometimes when we do decimals in grade 4 and they don't know what that looks like, they give you, like for example, 0.3 times 0.4, they come and they say 12 or 1.2. And they have no idea what happened because 3 times 4 is 12. But they have no idea that if you have 3/10 and you want 4/10 of that, it's impossible to have 1 something, right? And so, again, the message is, if you want to be an expert in 0.3 times 0.4, use the calculator. If you want to be a mathematical thinker that understands what is 4/10 of 3/10, then you have enough experience of this. And it's trusting the model. It's for students to trust their teachers when they're teaching them different strategies instead of challenging them. I already know that and so much more. I can count to 70,000. Yes, and that doesn't mean anything. What we're here to grow your mind and build a growth mindset, right? And so the more we trust, the more our kids trust their teachers and the better prepared they're gonna be. Yeah? Thanks everyone, you did great. You passed grade 10, okay? All of you, I'll give you your transcript.